All right, let's get right into today's explainer. We are diving into a totally crucial industrial skill that is absolutely going to take your maintenance game to the next level: VFD troubleshooting. Look, if you're in industry automation, electrical maintenance, or engineering, mastering the variable frequency drive is basically your golden ticket. So let's get to it.
Okay, picture this. You're out there on a loud, chaotic factory floor. Suddenly, a critical motor just stops. The whole production line grinds to a complete halt. Alarms are blaring, panic ensues, everyone is looking at you, and you've got to answer 3 immediate questions. What do you do right now? Why did the motor stop? And where is the fault code? Knowing exactly how to answer these questions under pressure is literally what separates the real pros from everyone else.
To get you troubleshooting like a pro, we've mapped out a clear path today. We've got 1. VFD basics and working. 2. Common VFD faults. 3. Step-by-step troubleshooting. 4. Safety and required tools. 5. Industrial case studies. And finally, 6. DEVI automation solutions.
Section 1. VFD basics and working.
First off, what exactly are we defining here? VFD troubleshooting isn't just randomly guessing or, poking at wires. It is the systematic process of diagnosing and resolving electrical and operational faults in variable frequency drives to minimize industrial downtime. Because let's face it, every single minute a machine is down costs thousands of dollars. You are stepping up to be the hero who gets things running smoothly again.
Now, a VFD isn't just some magic black box. It's an entire ecosystem of core components working together. You've got the rectifier, the DC bus capacitor, the heavy lifting inverter or IGBT module, the cooling fan, the control board acting as the brain, the display and keypad, your input-output terminals, and the communication ports. You really need to familiarize yourself with these because a breakdown almost always isolates down to just one of these specific parts. And honestly, understanding the working principle flow is huge. Troubleshooting is essentially just following this exact path. AC supply comes in, hits the rectifier, moves to the DC bus, flows into the inverter, and finally goes out for motor speed control. If your motor isn't spinning right, well, the break in the chain is somewhere right here in this flow.
Section 2. Common VFD faults. To keep from getting totally overwhelmed, we can group these faults logically. First up, voltage and current faults. You'll see overvoltage, which often happens if a heavy motor decelerates too fast and sends power back, undervoltage, overcurrent, or an output short circuit. Basically, these fault codes are just the VFD throwing its hands up and trying to protect its own internal circuitry from getting fried.
Moving on, we've also got operational and hardware faults. Things like a ground fault, overload, overtemperature, phase loss, cooling fan failure, or a major IGBT failure. An overtemp fault could literally just be a dead fan, or maybe the drive is suffocating under a thick layer of factory dust. Spotting these requires a keen eye and just knowing the drive's environment.
Section 3. Step-by-step troubleshooting.
So, how do we actually fix these issues systematically? Here is your initial diagnostics battle plan. Step 1. Observe the fault code. Step 2. Read the VFD display. Next, check input voltage, inspect motor wiring, and check earthing. Notice how we didn't just start ripping things apart? Most faults are caught right here in these first 5 steps before you even touch the really complex stuff.
Once you've cleared the basics, we move to deep testing and safe running. You'll measure output voltage, check motor insulation, verify parameters, and check communication cables. And only after all that checks out, you run the motor safely. It's all about building confidence at every single step of the process.
Section 4. Safety and required tools. Okay, hold on. Before you touch a single wire we just talked about, we absolutely have to talk about safety. These non-negotiable safety measures are literal lifesavers. Use lockout, tagout, wait for the capacitor discharge time. Seriously, a VFD can hold lethal voltage for up to 10 or 15 minutes after you kill the power. Wear your electrical PPE, ensure proper earthing, follow safe measurement practices, and always adhere to manufacturer guidelines. No shortcuts. Ever. As for your toolkit, every tool has a specific diagnostic purpose. You've got the digital multimeter for voltage and continuity, the clamp meter for checking current, the Megger is your absolute best friend for motor insulation testing. An oscilloscope is amazing for waveform analysis, and specialized software is what you need for deep parameter monitoring. Match the tool to the specific job and you are golden.
Section 5. Industrial Case Studies.
Let's step off the theoretical workshop floor. Where does this applied troubleshooting actually happen? Everywhere. Water pumps, conveyor systems, HVAC systems, the textile industry, packaging machines, CNC machines, and entire smart factories. A jammed conveyor belt or an overheating CNC spindle? The exact diagnostic logic remains exactly the same across all of them.
And why does mastering this matter so much? Because you are going to reduce machine downtime, save maintenance costs, improve productivity, and increase equipment life. And honestly, on a personal level, being the go-to person who can just walk up to a faulted drive and get a massive plant running again, that is going to open up some incredible better career opportunities for you.
Section 6. DEVI Automation Solutions.
Sometimes, though, you need to call in the grandmasters of automation for the really complex architectural system faults. And that brings us to DEVI Automation Solutions. They sponsor this knowledge, and their whole philosophy is right here on screen. Smart technology, powerful solutions, better tomorrow.
Just look at their professional services footprint. They cover everything: industrial automation, PLC and HMI programming, SCADA systems, VFD installation and troubleshooting, artificial intelligence, IIoT, and even smart agriculture. If you're dealing with serious automation challenges, these are the experts you want in your corner.
So, I will leave you with this final thought. Armed with this exact step-by-step roadmap, how much downtime could you save your factory tomorrow during the very next breakdown? Keep this guide in your back pocket, stay safe out there, and I will catch you in the next explainer.